Hey guys, how you doing? This is Coach Scott. Ooh, we're pausing. Yeah, there we go. This is like our fourth or fifth video in our series on stoichiometry. Today, we're going to be talking about limiting reactants, which is, and we'll play with this a little bit. I've got a little pogle on this. We'll get a good understanding of it. So anyway, hold on to your seats. So limiting reactants, right? So let's say I was building a car, right? Or baking a cake, either way. And I'm given so many cups. I've only got so much flour, right? If you think about it, in a chemical reaction, it's sort of like baking a cake or baking cookies or building a model or whatever. Not all the parts get used up. Not everything gets turned into the product. Then we have to think what happens when one of the reactants does get used up? Well, the reaction stops. All right, so we can't make any more if I don't have enough pieces. So let's say I've got 10 moles of hydrogen. 1, 2, 3, 4, 5. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I've got 20 moles of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Which of these are going to run out first? I've got 10, I've got 20. And if I look, it's a one-to-one relationship. One-to-one relationship produces one hydrogen molecule, and one chlorine molecule will produce one hydrochloric or hydrogen chloride molecule. So it's a one-to-one relationship. So for every one of these, I'm going to produce, and one of these, I'm going to produce two of these. So I use these 10 and break them up in there, and then I notice for every of these 10, I can only produce 20 hydrogen chlorides. That's it. All right. When I use up all the hydrogen, I can't produce any more of the hydrogen chloride. Did we use all the chlorine molecules or moles when I used all the hydrogen? No. I only used 10 of them. If I had 10 of these, I used 10 of those. So I've got 10 of them left over, right? Those weren't used. All right. So once that hydrogen gets used up, that limits the reaction. That limits the amount of material or limits the amount of products I can make. I can't make any more when the hydrogen gas is gone. All right. So I have more chlorine than hydrogen. So we would say the hydrogen is the limiting reactant. That limits how much I can produce. Now chlorine is left over after the reaction. So we call that as the excess reactant. It didn't all get used up. It's in excess. So the limiting reactant, or the reagent, is the reactant that's present in here's the key, smallest stoichiometric amount, not the mass. Now that's not always the one with the smallest mass. It's the one with the smallest stoichiometric amount. All right, and that's going to be the reactant that you're going to run out first, and it's going to determine the maximum amount of product that you can make. So these are worded a little bit different than a lot of our problems, okay? Because they'll give you the quantities of both of the reactants. So here, 10 moles of hydrogen and 20 moles of chlorine produce hydrogen chloride. Which of these is the limiting reactant or reagent? So what we got to do, here's our job. We've got to figure out which one of those reactants are limiting, because that's going to determine what the maximum amount of product that we're going to get. Now we'll sometimes call this the maximum yield. Now there's a lot of methods, and I'm going to show you a bunch in class, too, different than what we're going to do on the video. And I might make videos of them, okay? Here's one way. So first we can convert the given quantities into moles. And these are going to be your initial amounts of each reactant. Then we're going to divide each of these moles that we have by the stoichiometric coefficient from the balanced chemical reaction. This tells you how much we need for each of these reactants in the reaction. And whichever one of those has the smallest quantity, it's got to be the limiting reactant. That's confusing. Let's do one. I don't think it'll be as bad. So, here's the problem. When I have 10 grams of hydrogen and it reacts with 3.4 moles of nitrogen gas and it makes ammonia, which of these substances would be the limiting reactant? So first, we've got to get everything into moles. So for every 10 grams of hydrogen, how many moles do I have? Well, look at my periodic table. So 1 mole of hydrogen has a mass of 2 grams. So I convert to moles, click. So I have 5 moles of hydrogen gas. So my initial amounts are 5 moles of hydrogen and 3.4 moles of nitrogen. So I'm going to find the stoichiometric amounts for each reactant. So I take the initial amounts. Remember, we had 3.4 moles of nitrogen. And then I'm going to divide by that coefficient from the chemical equation. That's 1, so 3.4 divided by 1. So I've got 3.4 moles of nitrogen available. So initially I had 5 moles of hydrogen. I'm going to divide that by the stoichiometric ratio, or coefficient rather, 5 divided by 3, so I have 1.66 moles available. There's less hydrogen available, so that's going to be the limiting reactant. There's more moles, but I need more moles. Okay, see how I did that here. So, here's another example. I've got 10 moles of hydrogen gas, and it's going to react with 7 moles of oxygen gas to make water, which is the limiting reactant. There's our balanced equations. Luckily, both of those are in moles. I'm not doing any conversion from grams to moles. So I'm going to divide the 10 moles of hydrogen by the stoichiometric coefficient, 2. That means I have 5 moles available of hydrogen gas. Well, they said I've got 7 moles of oxygen divided by the stoichiometric ratio, 1. So I have 7 moles available. So what does that mean? Hydrogen gas is the limiting reactant. I'm going to use all the hydrogen, and I'm going to have 2 moles of oxygen left over. That's the excess reactant. Okay? Here's a real-world application. In a car engine, and I know some of you guys really like cars, I hear you as you drive into the parking lot. All right, octane in gasoline is combusted with oxygen to produce carbon dioxide and water that comes out through the exhaust. All right, and you can see our balanced reaction: 2 moles of octane and 25 moles of oxygen gas produces 16 moles of CO2 and 18 moles of water vapor. So the mix of octane to oxygen has to be just right. That's what the fuel injectors do. Or the engine's going to run too rich or too lean. Too rich means it's got too much octane. So here's the problem. If I've got 0.65 liters of oxygen and it's going to be mixed with 0.0061 liters of octane at STP, see if we're going to run too rich or too lean. Let's see. So those are our givens. Those are balanced reactions. So let's first of all find out how many moles I've got. So I'm going to find the moles of oxygen. So 0.065 divided by 22.4 will give me moles. So I've got 0.0029 moles of oxygen. So I'm going to divide that by the stoichiometric ratio to see how many moles are available. So I do that. I find out I have 0.000116 moles of oxygen available. Then I do the same thing for octane, 0.0061 divided by 22.4. That'll give me 0.00027 moles of octane. Then I'm going to divide by the stoichiometric ratio, and I see that I have 0.00014 moles. Okay, now let's analyze that. So I've got 0.00016, so that's less oxygen available than 0.0014 moles of octane. I've got more octane available than oxygen. So that mixture is too rich, and you're going to get a lot of knocking, right? That's not good. So let's look at a visual. In this example, okay, which one of these is the limiting reactant? So if I look, I've got 10 hydrogens, and let's see which one of those are. Well, those are the great ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I got 7 oxygens. Okay. And then I'm going to produce water. And I see that I have 2 of the red ones, or 2 oxygens left over. So which one limits the reactant? Well, that would be the hydrogen vapor, or the hydrogen gas, because I used all the hydrogen and I had 2 oxygens left over. They'll do that a lot. When I have 33 liters of nitrogen gas and I react with 12 grams of hydrogen gas to make ammonia, the hydrogen gas will be the excess reactant. True or false? I don't know. I'm going to have to do some math here. So I'm going to do some math. So I've got 33 liters of nitrogen gas. First of all, let's find out how many moles I've got. 22.4 liters. It's a gas. That's going to give me moles of nitrogen. 33 divided by 22.4. That's 1.47 moles. 47 moles. And I've got 12 grams of hydrogen gas times, let's see, for every 1 mole of hydrogen, there's 2 grams of hydrogen. So that's going to give me 6 moles of H2. So I'm going to divide by the stoichiometric ratio, 3, 2. So that's 1. So nitrogen is going to be 1.47 moles. And I can see 6 divided by 3 is going to be, hydrogen is going to be 2 moles. The hydrogen gas is the excess reactant. Well, there's more hydrogen than nitrogen, so true, it is going to be. When, our last one, 120 grams of zinc react with 2.1 moles of hydrogen ion, the zinc will limit the reaction. Let's see. So I've got 120 grams of zinc. 20 grams of zinc. Zinc has a mass of 65.39. One mole. 120 divided by 65.39. I get 1.84 moles. And I've got 2.1 moles of hydrogen ion. Okay. Divide by the stoichiometric ratio. Divided by 2. And I got that from right there and right there. So I've 2.1 divided by 2. That's going to give me 1.05 moles of hydrogen ion available. Well, I've got 1.84 moles of zinc. Is zinc going to limit the reaction? No. Okay, I'm going to use up all the acid or the hydrogen ion first. So that's a false. So, guys, that's it for limiting reactant. And we're going to be playing with this for a little bit throughout the year. Y'all know that. And so anyway, we'll do lots of practice of this, and then I'll show you some other methods. One of them is called the BCA method, and we'll just get it whatever works for you. Okay, guys, this is Coach Scott saying toodles. Have a great day and deuces.